Okay, thank you for coming today. Today we're gonna talk 2.2 determine volumes by slicing. Okay, so slicing means cutting, right? So cutting. So there is more advanced vocabulary, which is cross-section. So we talk about this one. Or maybe we talk right now. I want to bring the screenshot here. So this one. All right, so cross section. If we have cylinder, we cross section, then doesn't look good. Hold on one second. Then can you see that we cutting? Then we get the circle there, right? And we have pyramid. Then look, we have the square there, right? Can you see that? Oh, they said the rectangle. Okay, but we're gonna learn later on about this one squared. Depends on size of a perimeter, not perimeter, pyramid, right? How to pronounce? Okay, so cross section, just cutting, right? Cutting, we get the form of rectangle or square or circle like this, all right? Now, then volume. How do you get the volume? So normally we get the volume each side, right? Because unit, which is a cube, right? Cubic of the unit. All right. So if we have a rectangle like this, right, then we get the volume, which is length times width times the height. We denote it this way, right? Sphere, this is a rectangle. We have a sphere, then like this, like a 3-dimension. So volume, which is 4/3 pi r cube. How about cone? We have a cone like this. Then we have v equal to 1/3 pi r square h, which is r radius, and then height, in this case, the height here, right? Now, pyramid. So volume, which is 1/3 AH. So A in this case is area, right? So area times height, that is a volume, okay? All right. Then let us do this example. They say that we have the formula for the volume of pyramid as V equal to 1/3 A times H, which is area of this one, area, and height for this one, right? Now, they say that in here, we have a cross section. We had, they said a rectangle, but looks like in this case is a square, right? So inside here looks like a rectangle. Oh. Inside here looks like a rectangle, but here it looks like a square, right? So look, in this problem, they say that square base, right? Okay, now square base, then, so area, we can find area of a square. Let me see. This, okay, I'm gonna write down this. area of square, then we get side by side, right? So A equal to S times S. S mean doesn't mean anything, right? Just we are using the S or side, right? Side times side. So in this case, they are using A, right? As a side. They say that where A is the length in this case. And then I didn't write down where A is the length of the base. Okay. All right. Now, let me bring the picture here. This picture. Oh, I wrote down everything. I copy everything, but I did not. Okay. All right, then let's crop. Sorry about that. Pyramid right there. Okay. Now,
Professor, could you just scroll for a second?
Sure.
More up. Okay, yeah, thank you.
Okay. Now, look, since the area equal to S times S, which is S squared, right? Look, can you see that? This triangle, right side of a triangle, they get from the side, this part. Can you realize that? Okay, so S is there, S from there, right? And then S and H and A there, right? Okay, now let us find the S in this case. So look, we can say that similar triangle, right? Let me say S over A, so this one over this one. Then we can say that equal to this one over this one, right? Smaller size of a triangle equal to large triangle size, right? Similar triangle. Okay, let's write down. Let me see. By similar triangle, we can express S over A equal to X over H. Okay. Now, we said that area of a square is A equal to S times S, which is S squared, right? Let's see, they give us A, so let A equal to S, all right? Okay. Now, we're gonna solve for S. So if we want to solve for S, then what do you get? So probably we do this way, right? Multiply this one first. So we have SH equal to AX, right? Then divided by H. Then we have S equal to AX over H. Okay? Now, we have the volume. Okay? We want to find the volume, which is area of integration, then we find the volume. Okay, so Then let us make the bound, right? Your book indicate the limit. It's okay, lower bound, upper bound, or lower limit, upper limit, right? So we're gonna find from 0 to h, right? Okay, that interval, okay? So 0 to h. All right. Then we have the area of dx. We say the area, which is s square x. S square x. No, s squared, right? So we get from 0 to h and s squared dx. All right, then s, we say that we found what is s, right? So that is from 0 to h, s was ax over h squared. Now, we want to antiderivative with respect to x, right? So x is the variable, then a and h is the number, so we take out from the integration symbol, right? So we have a squared over h squared, right? Then we have x squared dx. Now, from 0 to h. Antiderivative x squared, what do you get?
X to the third divided by 3.
Good. From 0 to h. Okay, let us just using this space. All right, so we have a squared over h squared and constant. And let us substitute h cubed, and there is 0. So if you want to make 0, that's fine. Okay, then what do you get? We have a squared over 3h squared, then h cubed, then a squared h over 3. Yeah, this is a volume, same volume, which is we start in the beginning, right? So here. So we derive the formula. So I said a equal, I said a equal to s means just length, right? And length, and this is the side, same meaning. That means, okay? I don't get confused, all right? This length. This is side. So this is the pyramid, right? The volume is 1/3 a squared h. This is how we derive. Okay. All right. Let's move on. Now, so we have solid double revolution. Which is a slicing method. It's the same thing. Every time, if we have integration of the area, then we get the volume. So let us using that. The volume, right? Equal to, we have definite integration. Let's say that a to b and a of x dx, which is area, right? Okay. Because this come from same concept. If we want to know about the area, then we have integrate of from definite integration, then we do function. Yeah, so that is the area. Then if we have area, we have an antiderivative, then we get the volume. All right. Okay, now we have a solid of revolution. So they say the slicing method. Same as cross-section. Some book indicate the cross-section. So your book indicate the slicing method. Okay. Look. Let us do example. Find the volume of the solid of revolution bounded by f of x equal to x squared minus 4x plus 5, x equal to 1, x equal to 4, and rotate it about x-axis. Okay, so let me draw the approximately. So this graph looks like that. Parabola, open upward, right? And this one looks, there is the function f of x, and then they give us x equal to 1, x equal to 4. All right, so we have just one graph, right? And then there's a bound, 1 to 4, right? Not the bound. That's why your book indicate the limit, right? So lower limit, which is 1, upper limit, which is 4, right? Okay. We know how to find the area under the curve, right? But this section, we are learning how to find the volume under the curve, right? Okay. Then look, let me bring this picture. This is screen. What is that? Which one is this one? I think this one. Go to. Can you see that? They generated this figure. So we had, this is the function, which is a parabola, open upward. And then from 1 to 4, that's the lower bound, upper bound, right? And they rotate about the x-axis. Okay, so they rotate like that. Okay, then look, they generate rotate about the x-axis means that graph reflect here. Can you see? And then they generate this one. Okay. All right, now let us do this one. Did I write down? Okay, so let me write down this one. All right, how do we set it up? Volume, which is, in this case, 1 to 4. Area of, can you see? Okay, you cannot see the left side, you can see the right side. Look, can you see there is a circle? Okay, so if you see from this side, yes, it looks like oval, but then think about you are there, right? From standing here, x-axis, right? Looking at that, then you can see the circle there. Can you see? Can you image? Okay.
Yeah.
So then, yeah, very good. Now we can say that area of x was the area of a circle. Does anyone remember? Area of a circle. Pi r squared? Oh, excellent. Good. Oh, you are here. I don't say your name. Pi r squared. Good. So 1 to 4 pi r squared. Okay. Now, let's take out the pi. Okay. All right. From 1 to 4, r squared. Can you see that? We cannot use r squared because r is just a constant, right? We cannot have that. We cannot have everything of pi r squared, right? Look, in this case, the radius, right? Can you see that we do this one? Yeah. From here to here, the function is x squared minus 4x plus 5. Can you see that? Okay, so we're gonna use the function. So r squared will be f of x squared now. I don't remember, so let me write down this one. Copy. Paste. Okay, now, oh, sorry about that. I wanted to take out the pi out of the integration this way. Okay, so let's take out the pi, 1 to 4, and square them. Okay? All right, square them. I got that I worked earlier. Let me write down for you. Note x squared minus 4x plus 5 times x squared minus 4x plus 5. Okay, I have this one, x to the 4th power. Can I just write down the answer? Or just work everything? 5x squared minus 4x to the 3rd plus 16x squared plus 20x and 5x squared minus 20x plus 25. I got this one, okay? Then we have this one will be 1 to 4, x to the 4th power minus 8x to the 3rd power, 26x squared minus 40x plus 25 dx. Okay? Now your turn. Can you please antiderivative?
Okay. It will be x to the 5th divided by 5.
Excellent. Oh.
It will be just 8x. So,
X to the 4th power 2
yes.
plus
It's 26.
2/3 x to the 3rd.
okay, good. X squared 20.
Yeah.
Then last one is easy, right? From 1 to 4, I need your help, please. Okay, so pi 4 to the 5th power over 5 to 4 to the 4th power 26 over 3, 4 to the 3rd power 24 squared plus 25x. Oh, I don't know. Minus 1 over 5 minus 2 plus 26 over 3 minus 20 plus 25. Can you please try? You don't have to give it to me fraction. Just give it to me decimal if you want. Should I use the book answer?
I'm calculating.
Calculating? Okay.
I got a negative 11.86.
Oh, we get the positive. Oh, you mean the left side?
I got the left side has minus 1000.
Wow.
Give me a second. I'm still calculating.
Uh-huh.
What do we put into like where we have 25x?
I don't know. So I can just give it to you answer. Is okay?
I have minus 422 divided by 5.
49. Okay, let me see.
I have 84.4.
7, 8. I cannot find the pi in this case in the calculator. So what is to get this one? Okay, so I'm not just using the
Now I have another answer, 78 divided by 5.
Yeah, 7. Oh, you got that? Wow.
Yeah, I got
Wow,
78
excellent.
divided by 5.
Yes, 78 divided by 5, 78 over 5 pi, that is the book answer, okay? You got that, then you confirm, very good. In the chat, almost same, right? Okay, all right, let's move on. So in this case, they say that they cut, right? They cutting, then slicing, then they get the circle, right? So the area of the cross section means slicing, cutting, right? Then is area of circle. They cut in there, right? Here is the circle. Here is the circle, and this side too, right? Okay. Okay. Now, let's move on. Disk method. So disk method is the same as cross section. Hold on 1 second. Where is it? Disk. Disk. All right, so can you see that we have a very thin, so there is the a curve, the graph, right? So we have very thin rectangle under the curve. Then they produce a disk revolve about the x-axis. Can you see that? Okay. Then they get, like earlier, generate the shape like this. And then can you realize that they do rotating, revolve means rotating x-axis, then they reflect about the x-axis. So this graph, we can see that. Yeah. This one reflect here about the x-axis, all right? So we call this is disk method. We're gonna use just name of the method when we find the volume, okay? So this disk method. All right, then let us do problem. Okay, before we do that, we're gonna have the formula. Since we had the area of integration, then we get the volume, right? So every time they generate a circle, so we're gonna use pi r squared for area in this section, okay? Then r, which is the function, we had the experience, right? So this method, same as the cross section, slicing method, same thing, okay? So we had the experience, which is pi r squared. We're using pi, but r will be the function, all right? So we can derive the formula here, formula. Let's see. Let me write down disk method. Let me make short. The volume from A to B, we have a pi and the function square, okay? So think area of a circle. Pi r squared, okay? All right. Okay, let us do just the problem. So we had in the picture, we have, can you see that? The graph has x minus, sorry, yeah, that's correct. X minus 1 quantity squared plus 1, right? Let us this one. -1 to 3. Find the volume. Result by revolving. Oops. By revolving the result between f of x equal to x minus 1 quantity squared plus 1 and the x-axis over interval -1 to 3 around the x-axis. Okay, so they don't say where they rotate, but around the x-axis, this means rotate. X-axis. Okay, all right. So we're gonna set it up. Volume, which is from -1 to 3, then pi r squared, which is f of x quantity squared dx. Now, from -1 to 3, take out the pi. Okay, now f of x, which is x minus 1 quantity squared plus 1. Oh, it's broken. x minus 1 quantity squared plus 1 to the squared, right? Dx. All right, then from -1 to 3, lower bound, upper bound. Okay, so a squared, which is x minus 1 squared, then squared, right?
And divided by 2.
No. We have to simplify this one first.
Okay.
Yeah,
Nice.
good point. Plus 2 times plus 1 squared. Okay, please correct me if I make a mistake. Okay. Okay, now let us do from -1 to 3, and we have x minus 1 to the fourth power plus 2 x minus 1 to the second power plus 1. Okay. I think we can integrate from here. We don't need more algebra work. Okay, just using power rule, right? And term by term, we can do that. Okay, let us do this. Pi. Okay. We do antiderivative, we already have.
X minus 1 over 5 divided by 5.
Thank you.
To the fifth divided by 5.
Minus 1. X minus 1 to the 5 to the 5. I mean the over 5 plus we do antiderivative of this one.
Over x minus 1 to the third.
Over 3, good.
Yeah.
How about the last term? We have 1.
Just x.
X, excellent. Very good. From -1 to 3. Okay, now pi. Your turn. 3 minus 1 to the fifth power 5 plus 2/3. 3 minus 1 to the third power 3 minus -1 minus 1 to the fifth power over 5 plus 2/3. -1 minus 1 to the third power plus -1. Okay, your turn. Can you please calculate? 어떻게?
I'm calculating. I got 74 over 5. 74.
How about other people? We did not put the unit. Anyway, there is no unit. It's cube. Okay, so book has 412 pi over 15. Is it true? Floating point.
Not really.
Let me see. 412 times divided by 15. It's almost 86 in the chat. Two of you. Right? Yeah, it's okay. All right. Maybe you guys can do later at home. Okay, now let us do one more. Find the volume of the solid of revolution generated by rotating the region between f of x equal to square root of x and the x-axis over the interval short, make 1 to 4 around the x-axis. Okay. All right. So this means rotating x-axis, right? Around the x-axis means. Okay. Now we have square root. Looks like that. Okay, from 1 to 4. Can you see? I can say that this is a generating like reflect about the x-axis, right? Oops. I'll just leave. Okay, then okay. Yeah. So okay, so we're gonna find the volume pi and the function squared dx, then pi, we have square root of x, 1 to 4 squared, right? 1 to 4. Now, pi, we have x, 1 to 4. Now, with the antiderivative, what do we have?
X squared over 2.
Good. X squared over 2, 1 to 4. Easy. This one, right? So take out the 2. 4 squared minus 1. What do you have? 15 pi over 2. Easy.
We
So
have
okay. Cube. All right. What about the revolving y-axis, right? So we are using just everything changed to variable y. Okay. So let us do this one. Disk method for solid. Let me just do like that. Right now. Solid revolution around the y-axis. Then we're gonna use v equal to from C to D, lower bound, upper bound. We are using the y interval instead of x interval, okay? And using pi. And same thing, the function in terms of y. So we have g over y, quantity squared, then we say the dy, okay? Let's see, we have over here. We have a graph. Let R be the reason bounded by the graph g over y equal to square root of 4 minus y. And the y-axis in the interval 0 to 4. Okay, find the volume. So basically, in the y-axis. And then they said over y-axis. It's rotating about the y-axis, but let me write them one more. By rotating or around y-axis. Okay. All right. So let me bring the picture here. This one. This graph, g over y, for square root of 4 minus y. Okay, so we have the thin rectangle there, and then generate the shape there. Okay, can you see that? So they say that rotating about the y-axis. So we have y-axis there. Okay, rotating. Okay, then look, this one create. So basically, rotating about the y-axis means reflecting the graph y-axis, right? So there is like that. Okay, then we want to find the volume. So we make a 3D. Yeah, okay. Is okay? All right, so let us do this problem. We set it up, the volume, and pi, we have g of y, quantity squared, dy. All right, then pi is square root of 4 minus y. So we have the interval 0 to 4. So everything that given, right? So 0 to 4, 0 to 4, right? So y interval, we are using it. And quantity squared. Okay, now we have pi 0 to 4, 4 minus y dy. Now we can integrate pi, the first term, what do we have?
4x.
4x, very good. Not x, y. Y.
Oh yeah, 4y. Sorry.
Oh, okay, it's okay. Second term, what do we have?
Y to the second over 2.
Very good, thank you. Now we evaluate from 0 to 4 to find the volume, right? Pi 4 times 4, 4 squared over 2, and everything is 0 other side. Now, can you please calculate?
Uh, 8.
Oh, yeah, your classmate give it to me in the chat. Yeah, thank you
8?
so much. 8
Oh.
pi, yes.
Yeah, 8 pi.
Excellent. Okay, thank you, good job. All right, so you guys okay with this one? So far, so good, right? It's not that hard.
Yeah, this was actually really illuminating because I was kind of doing it wrong on the homework. I didn't realize that when you went around the y-axis that you have to have, you do everything in terms of y instead of x, and then the range also is in the y-axis, right? So you're going like vertical instead of like.
Correct.
It just
Yeah,
flips. It
wonderful.
flips everything. All right.
Yes. Okay. Now, we're gonna have a little bit difficult one. That's why I said that this section is a little bit harder. Okay. So far, so good. Basically, we are using just the area of a circle. Then that's a circle is just a function, right? That's why every problem has different function. We are using it, right? Now we have washer method. Okay. Do I have one? Okay. So. Okay, they say that we are using this method because when the solid of a revolution has cavity in the middle, Okay, think. We have a disk with holes in the center. Okay, let me draw. If there is drawing, okay, the last one, drawing. This one. Okay, look at the picture. Can you see that? We have two curves, okay? One, we have square root of x, f of x. We have the bottom one is g of x, which is y equal to 1, right? G of x equal to 1. Same concept, we have make a thin rectangle and then generate the shape, right? In this case, they do act around the revolving x-axis, means that revolving the rotating x-axis, right? So they have this one create like this, okay? So look, I said that revolving x-axis means rotating x-axis, right? So rotating x-axis means reflect about the graph x-axis, right? So this line, let me show you. There is already. So this line, it's 1. So reflect about the x-axis, so it will be -1. Yeah, okay. And this line reflect about the x-axis, right? Can you see that? Yeah. In this case, the reason they gives us 1 to 4, right? Yeah. Okay, now, can you see that? We generate the shape about the, can you see that there is a hole inside in the middle center?
Yes.
Yes, okay. Now, yes, then let's talk about the formula, okay? Since we have the hole there, right? We know that the volume we were finding so far, we had the integral of the area. So basically integrate of the area of a circle because everything generate the circle, right? Now, look, since we have hole in this case, right? We're gonna make the formula, okay? From here to here, there is the biggest R, right? The radius, because they say they're rotating about the x-axis, right? Okay, there is the biggest radius, and then rotating about the x-axis, so the smallest R will be from here to here, right? Can you see that? You guys okay with this one?
And yeah.
Yeah, kind of, right? All right, then, okay, so we can derive the formula, Walsh method. I already said the Walsh, right? Say it one more time then. Then in order to use washer method, right? Then we have to graph, right? Then whether we check they have a hole in the middle or not, okay? So then look, they said, let me make a little bit shorter. I just skipped all the words. And then the volume will be from A to B. Okay, and then we know pi r squared, right? But then in this case, we have the bigger r, right? Then we have a smaller r, right? Since we have a hole inside in the middle, okay? So normally we had pi r squared. Oh, r, no, pi r squared. Then that r will be just a function, right? So in this case, we're gonna do all right. Then whatever the upper one will be.
Is that an 8r squared minus h squared, or what is that?
Yes, I'm gonna make a function notation. So this will be a to the b pi, and we are using f of x. So f of x squared minus g of x squared. So dx. So like area we did the top minus bottom, right? So in this case, the f of x must be greater than g of x. Okay. Is it clear? So think outer radius and minus inner radius. From the rotating. Okay. All right. Let us do. Find the volume f of x equal to x squared. I'm sorry, x. And g of x equal to 1 over x. 104 around the x-axis. Let me check. I have the screenshot one out. This is the same one. Doesn't look like the same. This is the other one. Okay, let me draw them. Sorry. What is this? Volume? Sorry about that. I was crazy. Volume of solid of evolution by revolving the reason bounded. I wanted to make this statement because you know which one is top graph, which one is bottom graph, right? Bounded above by f of x equal to x. Then this is the top graph, right? Because they say that bounded above, right? And below by. So they say below by, so this is the bottom graph, right? G over x equal to 1 over x. In the interval around the x-axis. So around the x-axis means rotating x-axis, right? So let me draw. Okay. So this is f of x equal to x, straight line, okay? Now 1 over x looks like that, right? So 1 over x. No. Okay, never mind. Just draw like this. Okay, now we do rotating about the x-axis. So, okay, then the purple one reflect here, right? And then the black one reflect here. Okay, now we generate the shape. One to four. So supposed to be one, and four. Probably here. 4. So like this. All right, then can you see that there is empty in the middle? All right. This is empty. Okay, now let us think. Okay, let us think which one is outer radius, which one is inner radius. Okay, so outer. Oh, they already have just upper, in this case upper, right? So from the x-axis, the outer will be the top graph, right? And inner radius will be just the bottom graph, right? Because they're rotating x-axis, yeah? Is it clear? Okay. So let me write down, if we want, this is outer, right? And this is inner, small one is inner. This is inner. Okay, so then volume, which is pi, and we have f over x squared minus g over x squared and dx, and from 1 to 4 pi, okay, x squared minus 1 over x squared. Let me write down this way. Okay, we can integrate term by term, right? So can you please do that? Pi, the first term, what do we have?
X to the third over 3.
Thank you. And second term?
X minus 1.
X to the minus 1. Good. Very good.
Would that
So-
be, would it change it to a positive sign?
Okay, good.
Yeah.
Positive 1 over x. Excellent. Very good. You caught it. Right? Good. From 1 to 4. All right. Then pi 4 cubed over 3 plus 1 over 4 minus 1/3 plus 1. Can you please calculate? Your turn.
H1 over 4.
Did you say 81 over 4?
81 over 4.
Yes. Eighty-one pi over 4.
Yes.
Okay. All right. Good. All right. Now, this was good. Not too bad, right? But then washer, when do we use washer? If we're rotating about the line, there is we can see the gap, means that there is a hole in the middle, there is a hole in the center, right? Then at the time we are using the washer method. So this is a very nice problem, right? From now on, a little bit advanced. Okay, let us do 2 more problems, then we are done for today, all right? Okay. Find the volume of a solid. revolution formed by revolving the reason bounded above by, okay, bounded above by, so this is the upper graph, right? Top graph. So 4 minus x, good. And below by the x-axis in 0, 4. X-axis in interval 0, 4 around line y equal to -2. So I said that the last sentence said that around, that means rotating about that, right? So in this case, around the line y equal to -2, right? So this means rotating y equal to -2. Okay, let me bring the last screenshot picture here. Ah, they're already, I already make. Because I did not want to write down, that's why I screenshot everything with a problem. Anyway. Okay, this is the figure we have. So we have the graph, top graph. Then they say that bottom graph, x-axis here, right? Below by x-axis, okay, bottom graph. All right, but then they say that rotating about this line, y equal to -2, okay? Look, then we rotating y equal to 2, -2. Okay, then look. So we're generating the shape, right? So that. So I said that, right? I said that this line, since they said that rotating about this line, y equal to -2. So this will be I have this line, then look. I cannot do this one. This line, then this line reflect here. You guys notice that?
Yes.
Okay, because look, the unit 1, 2, 3, 4, 5, 6, right? That's a 6 up, right? So we do 6 down, then rotating here. Can you see? And also, this line reflect here about this line, right? So we have this line, so x-axis 2 unit there. So from here 2 unit reflect. Can you see? Okay. All right. Now, about this line, we rotate it, right? Then this will be bigger one, isn't it? this one is outer. This one will be outer. Can you say that? And this will be inner. Yeah. Okay, let us do this one. But then we have to make sure rotating y equal to -2. So this is outer. And this is inner. Okay, now I say the outer pi. Let's take out the pi. Outer will be, look, we have the function. Because the function has 4 minus x, then we have to add 2 because this line is y equal to 2. Do you understand? The function plus y equal to 2. There will be here. It's okay to you. So let me write down. This outer minus inner will be inner. We count. It's 2 units, right? Okay, then pi from 1 to 4, what was it? 0 to 4. Then f of x, we have f of x, which is 4 minus x, and plus 2 squared, 4 dx, okay? Now, pi, that is 6 minus x squared. Oh, we have to do work again. All right, then look, pi from 0 to 4, 6 squared, which is 36 minus 2 times x plus x squared, and minus 4 dx. There will be pi 0 to 4, 32, 12x plus x squared dx. Now your turn. Can you integrate?
Yeah, 32
Yeah. 32x. Second term.
6x to the second
Thank you. Third term.
plus x to the third divided by 3.
All right, so from 0 to 4, now, oh, you do. Minus 6, 4 squared, plus 4 cubed over 3, minus everything is 0 locally, okay? What do you have?
I get 160 divided by 3.
Very good. It's 160 pi over 3. Excellent. Okay. Now, this kind of problem is a little bit hard. Okay, now we want to do revolving y-axis. This is the one, last one. And then your book doesn't have the example about that, so I have one example from other book. So for sure. I think. Evolution around the y-axis. Okay, so let me make a short. We have v from C to D pi u y squared minus v. Wait a minute. It's supposed to be that y squared dy. In this case, the like earlier one, like top minus bottom, right? So this one, right minus left, like area between curves, right? So in this case, is that this one is less than the u of y, all right? Okay. Find the volume. So this is a y-axis. Volume of a solid of revolution formed by revolving the reason bounded by the equation. Given is y equal to 2x squared, x equal to 2, y equal to 0, around the y-axis. Okay, let me draw.
Oh, up for a second.
Mhm.
Just a bit more to the top for a second.
Okay. Okay, so let me draw. Okay, so we have a parabola, right? Parabola. And then x equal to 2. Let's say this is 2. Okay, y equal to 0. This is y equal to 0. And around the y-axis, so look, this parabola reflected there, right? Because of rotating about the y-axis, right? Okay, then 2 reflected there too, right? Then we can create. Okay, all right, then we can see that there is a hole in the middle, right? Okay, so move over inside, right? All right. Okay, so let us think. Y-axis. So we're gonna do dy, right? So all the variable in terms of the y. Then look, y equal to 2x squared. Let us solve for x. So we have x squared equal to y over 2. X equal to, let's take the only positive, plus minus square root of that. So positive square root of y over 2. Okay, now let us think about this. Y-axis, right? So from the y-axis, from here to here, outer, right? Okay. From here to here is inner, right? Okay. Now, oh, the interval. We are looking at the y interval. Let's see. When x equal to 2, what do you get the y value?
Zero.
When x equal to 2, we have y equal to 2 times 2 squared. We get 8. And then they give us y equal to 0. So we're going to use 0 to 8. That is lower bound, upper bound. Okay. So we have volume pi from 0 to 8. We have outer, which is right side in this case, right? So 2 squared minus inner, which is left one, which is square root to y over 2, quantity squared, then dx. You guys okay with this one? Okay. All right, pi from 0 to 8, 4, y over 4. Now, can you please integrate?
For x.
I'm sorry, oh my
minus-
God. No.
For
got
y,
it. Oh,
excuse me.
I'm sorry. Oh my God. So sorry about that. My fault. Okay, so 4y minus, we take out, what do you get?
Y to the second divided by 2, it's
Very
1
good.
divided y, never mind.
Okay, so for 8 minus 1 over 8, 8 squared, and luckily the other one is 0. So, okay, 32. 8 goes negative 8. Negative 8. 1 over 8. So what do you have?
Are you sure that we have that? Why don't we have a? Oh, never mind.
What do you have?
Don't we have 64 divided by 8, and it's just 8, and it's will be 32 minus 8.
We get the 8?
Yeah, I think we don't have, we have another ones and 1 over 8.
So
Okay, I think I'm wrong, so never mind.
no? It's 8 pi.
I got a 255 pi over 8. Is that right? I don't know.
I got that too.
255 divided by 8.
Pi, yeah.
So
32.
31 31.875 p.
So how much you got?
Oh, wait.
31.875.
Oh, wait. 250.
Yeah, it's 256 over 8 minus 1 over 8, and
over
it will
8?
be minus. No, it will be.
Why don't you give it to me answer, please?
It's 31.875.
Okay, so do you get the 255 pi over 8?
Divided by 8. Yes, I have
Yes.
this answer.
Is this answer? Can you confirm?
Miss Lee, I had a question. Why is it like when it's root y over 2, why is it y over 4?
Oh yeah, 2. So sorry. Yes. Yeah. Thank you so much. So it's 2. Sorry. Can you please work more? Everyone, go. Hurry up. Go. So 4, huh? Go. So then what do you get this one? 16 there? Is it 16? Yeah, correct, right? Ooh, 16 pi then? Oh, thank you. I cannot say your name. Thank you so
Yeah,
much.
I was trying to tell that we had a mistake there when we have a 16, but never mind. So we're
Okay.
good right now.
All right. Thank you for coming.